Alright, chalo, let's go and document some. Okay, let's pull the latest. हो गया उसके बाद इसमें तो कुछ नहीं है. Anything in here? No. And so we're in a 2D. All good. Okay, scrolling. Okay. Now I want to document. See the outline. 44 is here. Then we are in RadixMap and sort. Okay, before that, I was understanding how Radix sort works. We're checking some functionality. Okay, I know how counting sort works. I should compute the max. Then, okay, now if I go and take a look at Radix sort, it should be not here. Sort. Right, can I make it? Is there a user mode? Live caption by sharing. Okay, so we have Radix sort, most significantly significant. I want to go directly towards the implementation pseudocode. Okay, then we'll check here. Radix sort is a sorting algorithm that sorts elements by processing them digit by digit. It is an efficient. Okay, I get that in Radix sort we will use counting sort, yeah, count sort as a subroutine. But it was intriguing to know what does count sort return, because we are simply providing it the values, right, the digits as per to say. So it's difficult to know uh, how many of them would we get. Okay, rather than comparing elements directly, Radix sort distributes the element into buckets based on each digit's value. By repeatedly sorting the element by their significant digits from least significant to most significant, Radix sort achieves the final sorted order. Okay, here's an example. The key idea behind a Radix sort is to exploit the concept of place values. It assumes that sorting number digit by digit will eventually result in a fully sorted list. Radix sort can be performed using variation such as least significant or most significant sort. How does Radix sort? Okay, so we find the max is 3 digits, so we will iterate 3 times. No, sorry. Okay. Sort the elements. Sort the elements based on the unit place. We use a stable sorting, such as counting sort, to sort the digits at significant places. The most important to understand that the default implementation of counting sort is unstable. Same keys can be different order. To solve this problem, we can iterate input array. Yeah, we reverse order. Okay, right. That's why I did the reverse here to make it stable. Okay, now we convert the position, simply return the sorted array. We start at the reverse order to make it stable. Perform counting sort on the array based on unit digits. Okay, sorted on based on the unit digits. We have this. Okay, then it's simple. Let me hop on. Hmm. So I want to create a function Radix sort. Radix sort void Radix sort. We'll take the array and we'll take its size. Then what I want to do is find the maximum element in the array and max int max okay. When we find the maximum element in the array, I have a function for that. Find max will pass the array with pass the array. Okay, no, but it is like sort based on tens places. I have to pass an array of 10 only, 100th place. Sort the element based on 100 place, right? Look at this. Okay. Exponent. Get the max. Exponent equals exponent times n. Counting sort 10 of 0. Store occurrence array of I divided by exponent. Okay, mod 10. Okay, I get it. Yeah, right. I want to achieve, like, let's take a look. Say I have 20, 22, 23, or whatever. 45. I only wish to get the unit digits. So what I will do is I will divide it by 10. Well, will I divide it by 10? I won't divide it by 10. I will simply divide it by, say, 1 unit digit. So 1 divided by 20 gives 20, and 20 mod 10 mod function. What does mod function do? It will keep the digits between the value 0 to I will say this is k, so it will give 0 to k minus 1. So 11. See, this is exactly how I can represent is it is 2 times 10. Right. So we get 2 perfect tens. Mod. I'm pretty sure that's not how mod works. Okay, right. So we, if it is a multiple, I think that's how it works. For example, if I have 20, and 20 is a multiple, like I can 2 and let's see. it will be 10 plus 10. 10 more 10, 0. 10 more 10, 0. Answer becomes 0. Then we have say 22, right? Oh, even okay, 22 better. 22. This is 10 plus 10 plus 2. Say okay, any multiples of 10 mod, the multiple will exactly give me 0 because there is no remainder. Okay, mod gives the remainder, so when we divide it, what is the remainder? The remainder is 0. Okay, right. So that will be our unit place. So we'll have to this is counting sort. Let me make another function count for Radix count sort Radix. And it will take an array, its size, and then whatever the current uh, places. What do we gain? Digit. Digit place. Right. So we will first obtain the max. Max equals to find max array size. Nah, but actually I don't need to find the max because how many numbers will a single digit have, right? It's like a single digit will have number 0 to 9. So that is our count. Um, so 10 is the size of our. I don't need to find the max. 10 will go int count of size 10 where all will be zeros. Then what do I want to do is I take an output array. Okay, let's create two arrays and output of size k plus 1. Okay, I feel like I will save the and then copy it. I think basically that's what they are doing. Yep. Okay. So let's not create an output. We will hit int output of size n, and I initialize output. Yep. Okay. And same again I equals to 0, I less than n, I plus plus, I'd say output of I equals 0. And finally, we copy the sorted array from output, copy the sorted array from output back into what do I want to copy it and array. So for and I equals 0. Okay. Iterator int I equals 0 and creating it again and again. Let's keep just a single variable, initializing it nonetheless. So okay, but then it breaks. Let's not do that. Alright, and I equals to 0, I less than n, I plus plus, we go array of I equals output of convert the position to index, and then we paste it an output. Okay, so let's try this function for once, and we'll print array. Sort 70. Right, fine. It works. Great. Then, okay, I created, and what is the digit place? Then I wish to find. Okay. Find the max element. Compute the number of digits. Okay, how can I compute the number of digits it has? We can simply, okay, the number of digits can be given by I know a formula, like say 800, right? I'll keep dividing it. I'll keep dividing it by 10. Keep dividing it by, wait, keep dividing it by 1, then 10, until the division becomes 0. So like say for 1, it's the division is not 0. For 10, the division is not 0. For 3, import math dot include math.h. We get here and compute the number of digits. Okay, create an int digits equals 1. Assuming maximum digits are 1, then we'll go while max divided by power of 10 comma digits is not equal to 0. I want you to increment digits. Then what do? Then we simply go printf. Let me see the number of digits. What are the number of digits? Printf. number of digits, quotient digits. Okay, let's call this function. Let's say 32, 41, 405, 100. Now for the 66 and 29. Okay. Let's count for Radix. Special implementation. Special implementation of count sort for being used in Radix sort. Okay. Digits, right? Okay. Then I wanna go Radix sort. Let's try and make this. Number of digits 4933. Well, max 4933. Okay. This should work. Power of 10. Wait. That's how that power function works. And pages online. Power. Okay, power. Double x, right? Double x to function x raised to the power of y, right? X raised to the power of y, and I should the int. So let's try that again. Number of digits 3. Great. Okay, so there we go. We got the number of digits. The problem was that this is a float and you cannot really divide a float with an integer without messing thing up, statically typed languages. So there we go. And then I want to make int output with size n, but I cannot initialize it. Int digit place. Right. So we go here, set the output. Let me initialize output to 0 and less than n plus we go output of I equals 0. Okay. Next is to fill up, count the occurrences. So we'll go with for and I for int I equals 1. I think we start with 1. For instance, let me to obtain the count of each key j0. Okay, plus count of j, obtain count of each key in input array. I never increment j. Okay, j is the key. Then count of key. Okay, got it. Right. No, that one thing is later. Obtain the prefix sum. Okay, we want to the occurrence of equals 0 I less than the length and plus then we'll go j equals to the element, right? The element divided by the power of 10 comma digit place. Then I wish to mod it by 10. Then in the count array, say I'll set its position to increment its position by we have count array. Then we obtain the prefix sum, obtaining the key. Excellent. I'm pretty sure. Implement mine, then I'll take a look. Okay. Obtaining the key based on the place of digit. So we'll go divide it by power and then mod it by 10. Obtain the prefix sum, prefix is keep adding it onto the count of j is equal to count of j plus the other one. So we'll go point I equals to 1, I less than 10, which is basically the size of count. So the count of I equals to count of I plus count of I minus 1. As I do it, then map the positions into indexes for the output array. So I'll say for int I equals to 0 and search as j. We will put array of I because it contains the indexes. The indexes are the I should be less than n and I plus plus. Okay, first you obtain j equals to this thing. We have the key. Then we will obtain the index from position. J equals count of j minus 1. Then within the output of count of j, we will put array of I. Okay, see this right here is the index. Index of the number. Then we finally copy the output array into error point I equals to 0, I less than n, I plus plus. We will go with array of I equals output of I. Then we return int void count sort. We return. Okay, now perform count sort on all the places of the digits. We'll go point I equals 1, I less than equal to digits with I plus plus, and I will call the count Radix sort Radix on our array. Okay, I will name it digit base. Say number of digits plus number of digits, and we'll run number of digits, digit place, digit place should be less than or equal to number of digits, and we'll increment the digit place, and here pass the digit place. So now we take this. It is not sorted. Okay, so I feel like I must have done something wrong here. Obtain the key, we say key. Okay, count sort Radix, digit space, count the occurrences. Okay, so let me print. Hold up. Let's use the debugger. Go gcc -g. Okay, input unused variable output. Yeah, I don't need that anymore. Nice. Okay. GDP Radix. GDP. GDP is not. I don't have GDP. GW. Environment variables. Path. GW 32. Okay. I need to install. Let me see. What do I need to install? I wish to install ancestry packages. Don't have GDP. GW. Now can I create users? Package manager. I can use the package manager. Pacman. Okay. List all packages. Pacman. Pacman. Pacman dash Q. Capital Q. Okay. This is to. Okay, W64, right? Okay, W64. GDP, GCC, yes. W64, okay. Okay, now we should be able to call upon GDP. Still no? Okay, refresh this. Not make GDP. Yeah, okay. So let's go clear GDP Radix. Run. Right, okay, I want to set a breakpoint. GDP, 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 GDP. GDP. GDP usage. Michigan, how to debug using. Can I get a GDP man? GDP. Okay. Backtrace break file function or line. Break. Use the break keyword. Put a breakpoint at line. This is line number. I want to 86. Say line number 86. Radix of C node defined says Radix sort dot c. No, I'm gonna break Radix sort dot c. Radix sort dot c not defined. Exit. Okay. Things okay, clear. Okay, so I wish to find okay G Radix breakpoint at Radix sort dot c line by t6. Set a breakpoint at function. Okay, file. Oh, sorry. I break Radix sort dot c. Then line number 86. Breakpoint added. Then I say just run. We hit. I want to print j. Okay, j is 0. Let me check. Should it be 0? Um, for the first rate, it shouldn't be 0. It should be j also print I is 0. Right. Okay, so we go in here. We say I want the array of I, right? And then we divide it by the power of digit place. That is, I'm dividing it by 10 when I shouldn't be dividing it by 10. Should I be dividing it by 10? Digit place. Okay. Okay. Yeah, that's the problem. See, what I am doing is I'm dividing it by 10, then taking mod again with 10. But this, in case of this thing should be 1 in case of digit place 1. But the problem is that we are if I raise it to the power of 1, like say basically I have 10, right? I say my digit place variable is 1, so I divide it by 1. 32, but it should, even though I divide it by 10. Okay, yeah, because the remainder will be, because it won't leave a remainder. I feel like it will leave a remainder. Digit place j equals. Okay, I'll check for 75 first. Let's exit this. Yes, clear. We'll go GTP Radix break Radix sorted C break at 75. Okay, then we run it. I feel like I'm missing. Let me take here and this there. Okay, then if I go, okay, I want to print j. J is 0. When it shouldn't be 0, I want to print ARR of I, which is 32. right? That is correct. 32. Now if I divide 32 by and can I call this function? No. Okay, I cannot call this function directly as is. So you see, okay, this is 32. 32 divided by a digit place, print digit place 1. Okay. Let's see what does when we divide it by 10, what will it leave? J is 0. J shouldn't be 0. Mod 3. Okay, I feel like let's put it in this bracket and convert it into an int. I feel like it is converting it, the division. This division is converting it into a right. See, hold up. And then divide it. Let's say point integer. Integer. Cast it to be an integer. Let's exit it. Yes. Here we go into GCC Radix sort. Radix. Okay, then that's not what I want to do. I want to understand Radix. GDP Radix. Now I want to add a breakpoint at Radix sort.c line number 75. Let's go. Okay, let's print J. Sorry, print J. 0. Still 0. Still 0. Into power. Hey. Alright. So let me do this and add another bracket. Exit. Yes, I want to kill the process. Make it again. Let's run it with GDB. Put a breakpoint at Radix. So let's see line number 75. Let's run it. Let's print J. Still 0. Okay. Still 0. Okay, see when I divide it by max cost, so it's sort of last resort. Cast all of this to be an int. And let's try again. Can't I make? Hey, I can make the file in here. Okay. Dash or dash g radix sort.c dash radix defined. Okay. So we'll go this. Then I'll run this. Add a breakpoint at Radix sort.c 75. Now let's run it. Print j, still 0. What if I simply mod it? Right, we need to divide. Just mod it. Okay, let's see what is let's make it and then GDB breakpoint at Radix.c 75 and let's run it. Let's print j. J is still 0. Keep 10. Print of I 32. Okay, how is hey, I feel like okay. Let me. It is. I think it is not assigned yet. Next. Now print me j. J is 3. That is correct. Okay, I want to divide. Right. Okay. Mod. But j shouldn't be 3. If I'm modding 32, j should be in fact. Should j be 3? J should be 32, right? 32 mod. What's the remainder? It should be 2. 32 should be 2. Which is 3. You can say that. 0, 1, 2. Position 3. No, but position 3 would be for 4. So I need it to be 2. But which place? Places. Okay. Let me try this. I take the mod again. I first divide it by the digit place, which will be dividing it by 1, and then I take the mod by 10. So let's exit. Yes, I want to exit. Let's make the again, and then add a breakpoint at radix.c 75. Then I want to go run. Next, I want to print j. Okay, great. That is great. J is indeed 2. Right. So I okay do for this one, right? Okay, then I think I have fixed the problem. Let me just sort the array once and we'll see. So let's make the project and go Radix. Nah. So there's something wrong. 30 days at last. It is not sorted. It's less than. Let's. Okay, this part. Yep, this works. But rest doesn't. So number of digits equals 1. Let's try that again. Clear Radix. Nope. Copy. Count of j equals to count of j plus count of j, literally count of j plus plus. Wait. I should be less than n. Oh, that's why it is my fault. I should be n minus 1 and I should be greater than equal to 0. I minus minus. Okay, let me make it once again. Then we say what do we say? Let's say Radix. That was my only fault. Don't forget to start the loop in reverse. Let's make a personal note here. Yeah, the loop should be in reverse to make it stable. And that's all. Okay. So now I have understood how Radix sort works. Great. That's great. That's it for me.